And our next speaker, as we pull up the slides, is Ellie from Relativity Space. And I met Ellie the first time when she was at SpaceX. So I don't know if Ellie remembers this, but I was the guy that was like pestering you on LinkedIn. I was like, hey, I want to come, talk to you about, what's going on at SpaceX. So Ellie gave me a nice tour at SpaceX, and it was really cool to see what they were doing. And now she's with a really cool startup, Relativity Space. And fun fact, and Ellie can tell you more about this, but there's of all the football fans or soccer fans for America, she is probably the biggest in this attendance. So I don't know. I'll let her. She can talk about that if she wants to. But Ellie is currently the senior engineer at Additive Technologies at Relativity Space. After working extensively in traditional manufacturing world, she has turned her attention to the exciting world of additive manufacturing with Relativity Space. Eliana also serves as a woman in 3D printing and is an ambassador for Los Angeles. So anyway, Ellie, thank you for speaking today. I really appreciate it. And I think we are going to be controlling your slides. Is that correct?
Yeah. So I'll just ask you to move forward, like you can do so right now.
Okay. Great. Okay.
Okay, thank you so much, Joel, and the team for inviting me. I'm really glad to reconnect with you after all these years. So that it really is true. We met years ago when I was a SpaceX employee, and at that time, SpaceX was getting into 3D printing various parts and so on. And now I'm working at Relativity Space here in Los Angeles, California. It's a very small company, so you may not have heard of us. But I'll explain a little bit about what I'm going to speak about today is deployment of additive manufacturing as an enabling technology in space and space exploration. So please go forward to the next slide.
Cool.
So I have a brief agenda. Like I said, in case you don't know who Relativity is and what our mission is, I can explain about that. And I can give you a little intro into myself. Joel, you sort of revealed my big secret there. I am also on TV a couple of times a week. Yeah. But only if you have the NBC Sports Gold app. So it's a show called Fan Zone. They found me and they think I'm the biggest soccer fan in Los Angeles. I'm sure there are other people too, but anyway. I am also part of Women in 3D Printing. So I'll give you a little bit of introduction into why it's so popular. Why is AM for aerospace, where I come from, and now space is so interesting, why everyone's doing it. I'll give you a little bit of the history in case you guys aren't really familiar with. So I'll give a couple of classic examples of where it was first used, like rapid prototyping and repair items, which I think are the classic examples. And then give you a little snapshot into the current TRL or technology readiness level. And then for me, what's really interesting is the impact on space exploration. And that can be distilled into one word, which is lead time. And then a little bit of impact on the technology and economics and things like that, which I see from the supply chain that I'm very, very interested in, and also bolstering the supply chain. And finally, I'll leave you with a little tidbit, which is kind of like an interesting idea and thought-provoking kind of sentiment, which is how do you do 3D printing extraterrestrially, so basically not on Earth, in space or on other planets, and that's the goal, because it's pretty hard to take a 500-ton forge press with you to Mars. So anyway, if you want to forward the slide, please. So who's Relativity Space? We're a small tech company. We were started by two founders, Tim and Jordan. They were actually interns at Blue Origin. So always be nice to your intern, because one day they're going to be your boss. But they also came from the USC Aeronautics Engineering Program. And so when they graduated, one got a full-time job at SpaceX and one got a full-time job at Blue Origin. And they would text each other because they're friends saying, oh, this is so frustrating. It's so slow to get these metal parts. Why don't we just print our rocket? So they literally did that. They quit their jobs and they started their own company to 3D print a whole rocket. So fair play, because I didn't have that idea when I was 25 years old. And so here's a lovely picture of our crew, but it's already outdated because when this picture was taken, I think we were just over 100 people, and now we're approaching 165. I joined as employee number 20, and I was actually the first female engineer that was hired. So that doesn't really say very much, because we still need to increase those kind of diversity and representation numbers. So that's something that we're doing all the time. And actually, during time of COVID, we are hiring. So if you're interested and you have the skills, take a look at our website and then see if you have anything that matches your interests and skills on the careers page. But basically, the idea or our mission statement is to print the future of humanity on Mars or other planets too. And that way that we'll do that is by having a fully 3D printed rocket. So our customers at first will be commercial satellite people, anyone who wants to do space exploration. We've actually, if you followed us in the news, we've actually already signed a few customers, and they have faith in us, even though we haven't launched a rocket yet, but they believe in the technology. So that's a huge testament to AM being the enabling technology for space exploration. If you want to go to the next slide. So what is a rocket? Well, a rocket is a big flying cylinder. So rocket technology is ITAR and export controlled. So if you work for, or you want to work for a company in the US, just be aware of that there will be some restrictions. But essentially, it's a big flying metallic cylinder. And so this is an artist representation of our rocket, because we haven't actually taken off yet. But much like other people's rockets, our rocket will consist of a first stage that contains enough propellant to lift off and escape Earth gravity, and a second stage with a small engine that contains a payload that delivers that to the desired orbit, whether it's low Earth orbit or whatever. And so, yeah, the payload will be, at first, satellites, so many the CubeSats or microsats and things like that, equipment, and maybe one day in the future, crew. But let's not worry about that too much, because manned flight has a whole bunch of other things that we need to worry about. So we'll worry about getting off the ground first and then worry about taking people. But yeah, if you want to go to the next slide. So why 3D printing? Why did our founders, Tim and Jordan, choose 3D printing? So basically, based on traditional manufacturing, which is where I'm coming from, I worked in ring rolling forge press. I've always worked with mill products, traditional titanium mill products, billet bar, sheet, plate, coil, that kind of thing. And then trying to assemble a rocket using those traditional products, forgings, castings, whatever. There's a lot of parts, you know? And so 3D printing, you don't have to do as much assembly, you don't have to do as much fabrication, you can just print your part and there you go. So honestly, that's decreased part count. It's also an enabling technology for automation. So what Janet was saying in the digital transformation, that's the kind of thing that we see linking together with that technology. You can build faster, you can iterate faster. If something doesn't work for you, you can change it. So whenever I send drawings to suppliers, I say, don't worry about it, because if this doesn't work out for you, you can tell us what changes would be best. And so I really like that kind of partnership there. And so ultimately what AM provides is greater access to space for everybody. If you want to go to the next slide. So I'll give you a couple of like classic examples of why 3D printing and additive manufacturing was, you know, so fancy back in the day. I mean, honestly, like we've got some examples here, which is a classic example of 718 seal segment repair on a Rolls-Royce engine that they did with TWI in the UK. And then that's a classic example of using something where you don't have to spend a huge amount of labor costs and downtime to replace a whole part. You just add a little material to the place that you want to repair. Rapid prototyping also is a big one for a brand new design. If you want to put something on a commercial aircraft, it could take years to qualify a new part in a new material. And if you could just print it, you can test it and then see whether you need to iterate it or change, or what other things are working or not working with that part. So honestly, all that thing compresses again into the one key word that I keep saying, which is lead time. So, you know, you could be waiting weeks or months for a traditional metallic product, whether it's a forging or a casting or whatever. And quite rightly so, because other people in the aerospace supply chain have booked those slots before you. So if you're a small company, you don't really have a lot of options. Other things that AM really provides are things like customization and, you know, the ability to do unique designs or shapes or things that you could never do with machining a part, for example. So you can do custom tailored designs. You can get things that are unique to you, you know. And so obviously, when you're thinking about space exploration, you can sort of reduce things like the need for fixed tooling, which themselves have huge capex costs. So, and then if you think about how it drives the material supply chain, you can actually use better materials or stronger materials so that you can actually have light weighting. And by generative design, you also have light weighting. So you basically improve your buy to fly ratio, which is something that I always was very concerned with, or my customers were concerned with when I worked for a titanium producer. That would be the #1 topic of discussion, is how much they buy, and after they machine a part, how much flies. Okay, if you want to go to the next slide, please. So right now, we know that AM is actually in every industry sector you can think of. It's in biomedical, it's in consumer products, it's in automotive. I mean, there's fixture devices for biomedical, bone replacements, stents, screws, fixation devices, acetabulum cups, you name it. Even person had part of his rib cage replaced by printed titanium parts. And then obviously there are people doing parts for automotive, whether it's the chassis parts or individual small components for F1 and NASCAR, obviously. So all those things are happening, and they're happening right around us. If you want to go to the next slide, please. So just this is a very classic example of things you can do with shapes that blow people's minds. If you want to make a titanium sphere, you don't have to do a massive forging, for example, and then a bunch of machining. You can just print what you need, and then that's a huge sort of time saver, especially if you think you're going to make something that's huge and round, like the titanium part that was made for the Alvin submersible, which is made from an individually cast ingot and then forged into a round plate and then EB welded. Well, you can avoid all of that processing by just printing the thing you want and then doing some post-processing. So that's a really great classic example. If you want to go to the next slide, please. So yeah, in aerospace, and it's almost impossible to find any flying platform these days that doesn't have an AM part. So these are classic examples from GE, Airbus, and even military aircraft. But you can probably step foot on any commercial aircraft today and find something, maybe even like a seatbelt buckle, which is 3D printed. Next slide, please. So for us, this is a great one. Why are we so interested in 3D printing for space exploration? So I'm gonna just boast for a minute, but yesterday I was on a Zoom call with Rick Sternbach, who is the designer of the USS Voyager from the Star Trek show, and he also designed the Klingon attack vessel, the Vorta class, and Deep Space Nine space station. So he's actually going to be giving a presentation or a lunch and learn to our employees tomorrow, just to give some inspiration, because that's how we roll. But he was asking me if we use isogrids, and I said, actually, no, we're not, because a traditional isogrid would be a huge, thick plate which has the pockets machined out. And so if you think about that from a buy-to-fly ratio, that's a terrible, terrible waste. And the other traditional methods of making parts for rocket ships could be things like domes, where you take a sheet and you do some forming and welding, or you do friction stir welding, like these massive barrel sections, and you've got to have a huge infrastructure, not just the cost, but also the space to have that. And then you've got to train people up in it, obviously. So by looking at things that we're doing, additive manufacturing of rocket components, let's say the engine. So this is an early example of our Relativity's Aeon engine. And that's a nickel-based material. And then it was hot-fired, because we actually have a test stand down in Stennis, Mississippi at a NASA facility, which we rent. But yeah, so people, and not just us, but other people are also hot-firing actual rocket engines that are 3D printed today. If you go to the next slide, please. So what are we focusing on at Relativity Space? So right now we're focusing on two main methods, but I am fully aware that there are many other methods that are coming on. But these are the two that we're focusing on right now. So the first one is laser powder bed. I would say this is the more traditional 3D printing method for metallics that we use at Relativity Space. So I would say almost all of our engine parts, or the bulk of our engine parts and some turbo machinery is made all by laser powder bed fusion. The other technology which we have at Relativity Space, which is pretty amazing, is what we call Stargate. So it's not named from Stargate, the movie. It's named from a video game called StarCraft. I don't play that game myself because I'm not a gamer. But apparently there's a character in the game called Stargate, which is a machine that builds other machines. So that's pretty cool. So that's what we decided to call our system. So it's basically a wire arc additive system, which is very similar to WAM, basically. If you want to forward to the next slide, please. So, you know, as I said, the benefits for using AM for space exploration, one word, lead time, because the last time I inquired for titanium sheet from the mill, I think the lead time that they quoted me was 56 weeks. And I couldn't believe it. I really couldn't. I'm like, I know that there are constraints on how you make the material, how it's processed. It's a lot of energy that goes in. There's only so many people making that material at the mills in the world, and so many people that are qualified. And so that's the constraint there. By removing all those things, by using AM, you become the master or mistress of your own destiny. You take that processing time into your own hands. And so you take that away from the forgers and casters of the world, or having to wait 4 to 6 weeks for tooling for forging stock or whatever, right? And then also, like I said, for the example of things like friction stir welding, you don't have to have fixed tooling. And then honestly, by using all the software that we have these days, which is why we hired a lot of software engineers and automation people, is that we are actually doing real design for AM, and then using generative design and topology optimization to lightweight parts, or to remove features or walls and things like that that don't need to be there. And so along with that, like I said before, the development of materials, which actually needs a partnership from the material supplier, but lots of them are doing that, are for materials which give high strength without a lot of post-processing or the need for post-processing. So all those things are happening. And if you sum all those things together, what it means is that for spaceflight, you can optimize your payload. So that's why additive manufacturing is an enabling technology for space exploration. So if you want to go to the next slide, please. So if I talk about polymers, for example, so right now at Relativity, we are not doing any polymers at all, but we're fully aware that lots of people are. And so we have to maintain awareness of it. So this is a graphic that I just took from Waller's report, for example. And all it's showing you is that in the last 10 years, or plus 2 minus 0, that the market for AM in polymers alone has increased tremendously by this amount. That's 300 million or something like that, which is incredible. So all what that means is, you know, it's making things more efficient. It's reducing lead time, and time is money. You want to go to the next slide, please? So on the metal AM side, this is also growing too. Now this snapshot, I'm sorry, I can't tell you how many of these are like universities and tech centers and not actual industrial machines. So there could be some plus or minus with that. But there is no doubt that almost anywhere you go now, if you meet a supplier that's involved in the aerospace or space supply chain, they will have 3D printing. Even if they are material supplier number one, they still want to have a machine so that they know that the product that they can offer is printable. So you can see how that market is increasing. If you want to go to the next slide, please. So here's some statistics from MITx Pro. By the way, I did not start my career in additive. I came from traditional metalworking and I had to learn. And so one of the classes that I actually embarked on to educate myself in additive manufacturing was MITx Pro's class in additive manufacturing. But it's not a plug, by the way. It's just one of the very good courses out there that are particularly suitable for a vocational training certificate. There's also a very good class from ASTM, and there's other classes you could take, but I heartily recommend that as a professional, if you are in AM, if you don't have a real AM background and you're transitioning from the traditional metalworking world into AM, these are some sort of educational things that you could benefit from highly. But the statistics are that there are currently, well, I'm not really sure if this number is still valid with COVID, but 1,500 at the time this source took that information, I should say, 1,500 jobs listed on Indeed.com. I think most of the time we find people from LinkedIn these days. So if you want to adjust your resume to reflect that, you should partly do that on LinkedIn as well. But year-on-year sales of metal additive systems have increased, and then more and more venture capital money is going into AM companies and small tech companies that use AM. So for example, that would also include Relativity space. So we have some pretty cool investors. So Mark Cuban of the Dallas Mavericks fame is an investor. We also got Bond and Tribe and Playground and some other investors. And a very famous investor of ours, which just came on board recently with our Series C, is actor Jared Leto. So apparently he's very interested in AM, but why not? Because it's something where everybody needs to keep up with the latest technology, and certainly everybody's doing AM. So honestly, I think if you want to do a little bit more or get a bit further in your AM career, some kind of vocational certificate or training is highly recommended. If you want to go to the next slide, please. So here's a slide which I think needs a lot of discussion, and I don't hear enough of this topic from material suppliers who are in the AM supply chain. So what are the implications of additive manufacturing on raw materials? And then what are the views on sustainability and recycling? So this is something that I've noticed. Almost all of the people who supply feedstock for AM processes are the same people who make billet, sheet, plate, coil. And, you know, they see AM right now as maybe a small percentage of their total annual sales. And that is true, because especially for the high specialty materials, like say titanium, or the specialty steels, nickel-based alloys and others, some refractories and things like that, those materials in mill product are very constrained. The market for them is very constrained. And like I said, nobody wants to wait 56 weeks for titanium sheet. So they have maybe one or two atomizers in addition to all the standard mill products that you find at a steel mill or a titanium mill or whatever. And what they see is that AM is a pretty good market for them to get into. Everyone's doing it. And so what can we offer? And then what they don't realize is that the customers, the end users out there, will take as much as you can give. If you can make £20,000 now, but you can't replenish until another 6 months, I'm going to be waiting a long time for that material. So how do you ramp up your supply chain? And how do you deal with the tremendous amount of energy that's involved in, let's say, gas atomization or whatever it is? And then who gives a thought to recycling all the leftover material or powder that's become unusable because it's oxidized, or it's been through a machine 10 times and now it's built up some kind of cast layer or something that makes it difficult to flow or just difficult to even melt? And then who gives a thought to all those prints that failed because a laser cut out or because a recoater blade fudged something up? And what do I do with all those unusable parts? Yeah, I can cut it up and I can look at it, the microstructure. Okay, yes, that's where the laser failed. but it's completely useless to me now. Who is going to take responsibility for that waste stream and make that material into something that's reusable? So honestly, what are our responsibility as end users? So I know nobody's really talked about it in all of the webinars on online seminars that I've seen so far during time of COVID. But I think this is something that is super important to actually start a dialogue on. So if you want to go to the next slide, please. So I've just got a couple of minutes left. So that's really why the additive manufacturing as a technology has a huge impact on space exploration. All the things that we've talked about, lightweighting, better design, stronger material, you know, but all those things result in benefits to your customer. Your customer can get to space faster than waiting for a traditional rocket. If you want to go to the next slide, please. And this is very interesting. So people have been doing 3D printing in space. The ISS does have a printer. Okay, it's not metallic right now. It's polymeric, but they've been able to make their own parts, so spare parts, tools, widgets, and things. And fortunately, the feedstock was not overly complicated or dangerous. So I don't think anything metallic has been printed in space yet. If you want to go to the next slide, please. But people are thinking about printing on another planet, and that is going to happen as we start going out to the stars, whether it's the moon or Mars. People are going to be thinking about printing extraterrestrially. I know you're laughing there, but it's a thing. And so here's an artist's rendering of what it might be like to build a habitat on the moon, for example. And so if that's true, what's the feedstock? You know, is it going to be metallic, or will it be ceramic? Or if it's metallic, it's probably not going to be powder. It's probably going to be wire, because powder tends to float away. And depending on the material, it could be pyrophoric. So that's not cool. If you want to forward to the next slide, please. So basically, AM is changing the way that we build rockets, and this is what people want. They want it bigger, taller, faster, stronger. And so whether you're trying to build a part that's taller than me, or you're trying to build faster with a better sort of resolution and deposition rate, or whether you're trying to overcome things like reflectivity and other problems from green lasers and things like that. Sorry, green laser could be, or blue lasers could be an example of where that's a technology that can help you actually overcome some of those problems. If you want to go to the next slide, please. So I don't know if you can press the button, but I have some time-lapse video which shows a fuel tank being printed. So this is printed on Stargate. So Stargate, as we know, woo, is the world's biggest 3D printer because it's really tall. So that we know of. So this is the very first time we successfully printed a fuel tank, and we did that over the weekend of Formnext 2 years ago, but that all took about 10 days, and we've cut that time to a fraction right now because of all the learnings that we've had. So yeah, AM is changing the way we go to space. And with that, you can forward to the next slide. And if you have any questions for me, Joel?
Yeah, thanks, Ellie. Well, I'll first start, the AV team's pulling up some questions, but I'll first start with, how are you like coping with COVID, and like what are you doing? You know, obviously we're all doing something different, but what are you doing now? I mean, I know Premiership, they have there's some soccer games going on. So I saw the German Cup the other day. There was no fans, but at least, you know, we get to watch some sports. So how are you doing?
Yeah, well, I could talk about Relativity for a start. So we actually decided to do work from home before the rest of California went into lockdown. So we spent a whole week getting hardware and VPNs to people. So we were prepared. Great. And we also knew that with restricting people in the lab, that some of our development work would be slowed. So what we've done is we've initiated a COVID task force to understand how to protect our employees. So we knew that we have to keep a launch schedule, but we can't stop our rocket development. So we have been doing that. I myself, because I wanted to help, I have been sewing cotton face coverings like a freak. I've made so many, and I've distributed those to our employees. So, you know, if they want to go grocery shopping or whatever.
Sure.
And as part of Women in 3D Printing, my co-ambassador for Los Angeles, Lindsay, has also been printing these, which she face shields.
Nice.
So here's a great example of a file that's available on the America Makes website, and it can be cleaned and with wiped with alcohol. And so that's a perfect way to protect yourself. And she's distributed 500 of these to clinics and medical professionals in the Los Angeles area. So that's the kind of thing that we've been getting involved with. Personally, I've been just trying to help any way that I can. But as far as my work is concerned, most of my suppliers were out of town. So travel, there's no way. I cannot go to Germany, especially if the EU are banning people from the US. So I'm not planning to go to Formnext. I'm not planning to go to the Wire conference in Dusseldorf. Until there's a vaccine, we're just going to try and stay safe. But there's still tons of work to be done. And so I am still working with all my suppliers pretty intensely. Yeah.
Great. No, that's excellent. And it's awesome, like, yeah, giving back to the community and things like that. That's awesome to see. Here's a question. So what is your opinion on printing using planets' natural resources, such as lunar regolith? Regolith? I don't know. I don't know what that word is, but maybe you do.
Yes. I mean, most metals have to be extracted from some kind of ore.
Mm-hmm.
So that's why the cost of titanium is so expensive, let's say, because it's only one kind of ore, which gives you enough titanium metal yield. So I think that's a good, if you can live with whatever other impurities are in the rock or the ore, and I'm not a mineralogist, so I really can't tell you too much about that. But the extraction process on Earth is very expensive and very energy intensive. So if somebody can figure out how to use that, you will cut the cost tremendously. You'll also cut transportation costs, which could be a bit of a problem if you're trying to launch to another planet. Sure. And carrying all that rock with you. Yeah.
Hello.
I can only imagine. Yeah, so many challenges. So here's another question. Are there opportunities? This is for, I think they're looking for international people in the field. And I'm not sure if it's, maybe speak to it in Relativity, if Relativity is looking for like international assistance too, or, employees. And then maybe as AM as a whole. I mean, obviously you can do additive manufacturing anywhere. So, but yeah, maybe you want to answer those two.
You can. If you want to work for a US-based company that has anything to do with rocket or defense, you need to be a US person. And those are becoming, if you're a foreign national, very difficult to get. But I would say don't give up, because there are plenty of other countries that have space programs. For example, European Space Agency, there's stuff going on in UK. There's an Indian Space Agency. They tried to do a lunar probe a couple months ago, if you remember that. So there are opportunities worldwide. And also, don't forget, AM is in automotive, commercial aerospace, biomedical. There are even things like the jewelry industry, consumer products. They don't have as bad restrictions on your nationality. So I would say, please consider that when you think about a career in AM.
Great. Well, anyway, thank you, Ollie, so much for speaking today. I really appreciate it. And yeah, we'll definitely be in touch. So thank you, Ollie, and everybody else can give her a round of applause. So thank you.